everyone! In this section 8.3, we're going to be talking about trigonometric integrals. So these integrals are ones that involve combinations of the 6 basic trig functions. And then we're going to use identities to transform the integrand so that we can figure these integrals out and make them look easier or better to work on. And so we're going to basically break this into 4 different categories of types of integrals that are also part of this trigonometric integrals. Alright, number 1, we're going to look at products of powers of sines and cosines. So our integrands are going to have sines and cosines or combinations of those 2 functions in them with exponents on them. Number 2, eliminating square roots. So these are going to be integrands that have our trig functions in a square root. Number 3, these are going to be integrals that have tangent and secant or a combination of those but with exponents on them. And then number 4, products of sines and cosines. So this is not the same as number 1. Number 1 had powers. So we were multiplying sines and cosines, but there was exponents on there. This time we're going to be looking at maybe just like sine 2x times cosine 3x or things like that. So the exponents are going to be like an invisible 1 for multiplying sines and cosines. Alright, now starting with our first topic in this section, products of powers of sines and cosines. So this is going to be integrals that involve sines and cosines with exponents on them. And so m is going to be the letter we use to represent the power on sine. And then cosine is going to have an n for its exponent or power. So this is going to be for cases where m and n are integers. So remember what that means. Those are whole numbers, but including the negatives. And but they're greater than or equal to 0. So basically, just think of like whole numbers. And then just a quick reminder on the notation for powers with trig functions. And if this helps you, I don't want you to get confused with the notation. So just remember when you see something like sine to the m and then x, it really means sine x to the mth power. And then over here, very similarly, this really means cosine x to the nth power. So if it ever helps you to rewrite it, feel free to rewrite it like this. Okay, so when we're dealing with powers of sines and cosines, we actually have 3 different cases we're going to go through, and I'll show you an example for each. Case 1 is when m is odd, so notice that's the power on sine. Now what's going to help us here is to think of how we can write an odd number. So if a number is odd, in this case m, you can rewrite it as 2 times k plus 1, where k is just some integer. So if you've never seen this notation before, just think about it for a second. Any odd number can be written like this. So let's just go through 1, 3, and 5, the first few positive odd numbers. 1, and you don't have to write this part, just think about it. So 1 is 2 times 0 plus 1. 3, the next odd number, is 2 times 1 plus 1. 5 is 2 times 2 plus 1. So this is a generalized way to write any odd number. So that's going to be our case 1. Now case 2 is going to be when n is odd. So n is the power on cosine. So very similarly to what we just talked about, this is when n is of the form 2k plus 1. Now our third and final case here is if both m and n are even. So we're going to break this apart and show you 3 different examples, one of each case. Now getting into our first example, example 1 is going to be case 1 where m is odd. Notice the power on sine of x is the third power, it is an odd power. So the very first thing I'm going to do with this integral is I just want to recognize really quick, and sometimes you could just do this part in your head, how can I rewrite this odd power of m in terms of 2k plus 1? Okay, because that's going to help us do our step 1 in this process. So if you think about it, what does k have to be to make this true? Well, k has to be 1. So this is the same thing as 2 times 1 plus 1. And so what we're going to do, and I'll break this into a step, we'll call this step 1, is we're going to write our sine function part of our integrand differently, breaking it down as 2k plus 1. So we're going to write sine of x to the 2k plus 1 power. So I'm just changing the notation like I said a little bit ago. I'm going to just put it outside the parentheses here to make it a little bit more clear for what's happening with the exponents. So write sine of x to whatever power you have, in our case it's 3, as the following. So we're going to write this as sine of x to the 2k power times sine of x to the 1 power. And this step right here, this you can kind of skip, but I wanted to show you the algebra there to get to what we're really going to write it as. So this is the same as sine squared x to the kth power times sine of x. Okay, so this is more so what you want to focus on right here. So you're going to write what you have, in this case sine x cubed, as sine squared x to the, this is going to be for us the first power, times another sine x. And so what we have is our integrand here, our integral here. This is sine squared x. K, remember in this case, k was 1 to the 1 power up here. I'm not going to write it, it's invisible 1, times sine x. And then we already had a cosine squared and dx, so we're going to bring that back in. And then if you want to verify, hopefully this makes sense to you, if you multiply these back together, you're going to get right back to sine cubed or sine x cubed. Alright, so that's step 1. So we just finished step 1. Now we're going to move on to what I'm going to call step 2. And step 2 is going to involve one of our trig identities. So we're going to use the identity, the Pythagorean identity, if we solve for sine squared. So remember, sine squared x plus cosine squared x is 1. So if we solve for sine squared x, we get that sine squared x is 1 minus cosine squared x. Okay. A lot of times with integrals and trig functions, identities from your trig class come up. So this is one big one that we use quite often. And so you're going to use this identity by substituting it into your integral. In this case, let's choose a new color here. Right here where there's a sine squared, we're going to replace it with what it equals in terms of cosine squared. So this becomes 1 minus cosine squared x times what was already there. I'm going to rearrange because it's going to lead me into my next step. I'm going to put this other cosine squared next to where we're already working. And then I'm going to just move this sine x to the back over here. So sine x dx. Alright, and now that's step 2. And so step 3, hopefully this is going to look a little better to you already. Maybe you can even see where we're going to go with this. If we choose to use u as our variable in the terms of cosine here, cosine x, our derivative of that would be present, which is the sine x. So we're going to go ahead and let u equal cosine x. And so if we choose that, we know that du, derivative of cosine x, is negative sine x dx. And then let's just take this negative over. So we have negative du is sine x dx. And then we're going to substitute. And so let's just underline some stuff here. This right here in the back, this is now negative du. And then everywhere we have a cosine squared, or cosine x, we're going to square it up here. That's the u part, okay? So that's what we have for u. And then let's go ahead and put that all together. This is 1 minus u is cosine x, so u squared times u squared, right here, times negative du. So let me make it very clear, it's not minus, this is times negative du. Let's make this look a little better. I'm going to factor out that minus all the way to the front, and I'm going to distribute right here as well. So this is negative of our integral u squared, because I'm distributing, minus u to the 4th du, and this is so much nicer to work with. We can figure this out, no problem. So if you want to, go ahead and pause this and integrate right here, then I'll show you what you're going to get in just a second. Alright, if you did your integration, you got negative u to the 3rd over 3. Going to distribute here, plus u to the 5th over 5. I'll leave the plus c off to the very end. Let's put our cosine x back in. This is negative. And then I won't skip this step this time around. I'll skip it maybe on the next one. But this power is technically on the whole cosine x. Okay? And then I'm going to bring it in, and that's what I'm saying. You could skip this part in the future. Plus cosine x to the 5th over 5. So this is the part that you can just jump to if you see it. This is cosine cubed of x, or cosine x cubed, over 3, plus cosine x to the 5th over 5 plus c. Final answer. And this was what our integral looked like originally. So that's an example where the power on sine is odd, and there's a mixture of sine and cosine here. So we'll do another example in just a moment. All right, taking a look at example 2. This is case 2 because n is odd. Notice you have cosine to the 5th power, and so the power on cosine is n, and it's an odd number. Also notice that m is 0 here because there's no visible sine of x, just meaning that sine of x is to the 0th power. It's like there's an invisible 1 times sine x, invisible 1 instead of sine x. So let's go right into it. We know that n is 5, so if we rewrite that as 2k plus 1, we know that that's going to be 2 times 2 plus 1 to give us 5. And so very much like our last example, step 1 here is going to be to rewrite this. In our case, it's going to be rewrite cosine of x to the 2k plus 1 power as, and we're going to jump right into how we're going to write it. This is going to be cosine squared of x to the kth power times cosine x, okay, because 2 times k plus 1 for the exponent there. So for us, what that looks like is cosine squared of x, k is 2, so squared, times cosine x dx. And that, if you need to check, square this and you get 4, or multiply here, you get cosine to the 4th times another cosine, that is cosine to the 5th. So that's step 1. Okay, now step 2, very much like example 1, we are going to use our trig identity, again the Pythagorean identity, just this time we're solving for cosine squared. So we're going to use the fact that cosine squared x is 1 minus sine squared x. And so we're going to substitute that quantity right in here for cosine squared, and our integral becomes 1 minus sine squared x, quantity squared because it was already squared out here, times cosine x dx. Okay, now step 3, and hopefully it's looking a little better already because now we have a mixture of sine and cosine, and we can let this part be u, and then the derivative is going to be present. So notice if we let u equals sine of x, then du, derivative of sine, is cosine x, is cosine x dx. And we can sub that directly in here. So we're going to substitute du for cosine x dx, and then substitute u for sine x. And we end up with 1 minus u squared, quantity squared, and then in the back all of this is du. And then again, this is so much nicer than what we started with because you just use our power rule here. So go ahead and pause this, work this out. You do have to FOIL this and see if you can integrate this, and then check back with me in just a second. Okay, I'm going to go through it real fast. If you already did it, let's see if you got the same answer. So we're going to FOIL this out really fast. This is going to be 1 minus 2u squared plus u to the 4th du when you FOIL this binomial out. Then let's integrate each term. We get u minus 2u cubed over 3 from this term plus u to the 5th over 5 from our last term. And I'll put the plus c on at the very end. Let's go ahead and let me remind you what u was. U for us was sine of x. So let's resubstitute that back in. So this is sine of x minus 2 sine cubed x over 3 plus sine to the 5th x over 5 plus c. A little ugly, but it is the right answer. So this is the antiderivative of this integral up here. Okay, and this was example 2. So we'll do one more where we do case 3, so that example 3 will deal with that. Okay. Example number 3, case 3. M and n are both even. So notice the power on sine is 2, the power on cosine is 4, so they are both even powers or even exponents. And so what we're going to do in this situation, case 3 is a little different. We're going to do our step 1 is to go right into using some of our trig identities. So we are going to use our double angle formulas modified a little bit for sine squared and cosine squared. So we're going to use these two identities. The fact that sine squared x is 1 minus cosine 2x over 2, and cosine squared x is very, very similar with a plus sign. 1 plus cosine 2x over 2. So these are two formulas that it's nice to know them in this form because then you can recognize when to use them. But they do come from your double angle formulas for trig functions, because notice this is cosine of double an angle, twice x. Same thing here. All right, so we're going to substitute these two in to our integrand right here. So we have integral of, now where we had a sine squared x, we're going to replace it. Okay, so our sine squared x is the same as this quantity here. So we have 1 minus cosine 2x over 2. And then now be careful here. In the back, cosine, this is cosine to the 4th power. This is a formula for cosine squared. And so if you think about it, we're basically squaring this to get to a 4th power. So if I say cosine squared squared, that represents what we have here, cosine to the 4th. So we're just going to write this quantity squared. And so we have 1 plus cosine 2x over 2, quantity squared dx. All right, now if you want to try this out, you're going to FOIL and FOIL again. So you have this quantity times itself, this numerator, because you're squaring it, and then you're going to multiply that over here. So feel free to pause it and try out the FOILing or multiplying, but then I'll work it out for you also in just a second. Okay, let's work on the algebra. I did factor out a 1/8 from the denominator, so we had a 2 on the bottom of one fraction and then a 2 on the bottom of this fraction, but it got squared. So it's 2 times 2 times 2. That's why there's a 1/8 here. Now, let's see if you already worked this out. Hopefully we'll get to the same point. I'm going to start with the part that's squared. So I'm going to leave this first factor out front here. And then if we FOIL this out, we get 1 times 1, 1 times cosine 2x, and then that gets repeated. So that's 2 cosine 2x, and then cosine 2x times itself, so cosine squared of 2x. All right. Now, I'm going to show you something. If you already are good with multiplying polynomials or multiplying a binomial times a trinomial like this, then feel free to skip this, but I do want to show you for any of you that kind of get confused when this happens. So the box method is really useful when you have multiple terms like this. So this longer one I'm just going to put on top. So this is 1 plus 2 cosine 2x plus cosine squared 2x. And then on the side I'm going to put the other factor. So this is 1 minus cosine 2x. Not very nice looking. Hopefully, let me make that better. Minus cosine 2x. Okay. And so what you can do, the size of this box, you have 2 terms times 3 terms. So 2 times 3 is 6. This box is going to have 6 squares in it. And then with this box method, you just multiply row times column. So this is 1 times 1, 1 times, I like to keep the signs with it too. 1 times 2 cosine 2x, 1 times cosine squared 2x, 1 times negative cosine 2x, 2 cosine 2x times negative cosine 2x. Okay, so coefficients. 2 times negative 1 is negative 2. Cosine times cosine is cosine squared when the arguments are the same. They're both a 2x, so we can go ahead and say that's squared. And then the last box here. Positive times a negative is negative. Cosine, notice the arguments are the same, 2x. So we can multiply cosine times cosine squared. So that's cosine cubed 2x. And the nice thing about this method is that the diagonals are usually like terms. So you can combine these terms here, and you can combine these terms here. And so our integrand, let's see, we have a 1/8 out front. We end up with 1 plus, this is a total of 1 cosine 2x, Over here, this is a total of -1 cosine squared 2x. And then last term, minus cosine cubed 2x dx. All right, now this is getting better, but it is still long and tricky. This is a long integral to do, and I'm going to break it down all the way for you. But initially, it didn't quite look this long, but it's getting longer, but it is getting better. So I'm going to make some notes here. The first two terms, we can integrate this no problem. Actually, let's do them separate. The first one, the integral is super easy. We know that. It's just x. But over here, we can use u substitution and figure this out pretty quick. Now, what I want you to notice here is this is another even power for cosine. So this is like case 3 again. And so I'm going to just mention that. Case 3 again. And I just say it like that because we're going to use our double angle formula again here. And then over here, what I want you to think about is that this is an odd power of cosine. So this is back to case 2. So this problem is pretty lengthy because we're using multiple cases within case 3 initially. So we're gonna work it out, and let me label these because we're gonna do them each part. I'm gonna call this part 1, part 2, part 3, and part 4. And then at the very end, we're going to add up all these answers, but we're going to break them into parts just so you can see each one. Okay, so I left what we were talking about here just to remind you. We're going to break it into 4 parts, 4 different integrals. I'm going to go ahead and distribute that 1/8 factor to all these so I don't have to think about it later. So very first integral in our 4-part process here. This one's the nicest one. This is just 1/8 x. All right, that one's done. So I'm going to box that in, and we're going to add that into our answers later. Over here, we do need to use u substitution, or if you can see it, you can kind of do it in your head if you are able to see that. 2x for u, so du is 2 dx, and so 1/2 du is dx. And so when we substitute that in, that's 1/8 integral of cosine u times 1/2 du. Let's factor out that 1/2. That's 1/16 integral of cosine u du. So that is 1/16. Which function's derivative is cosine? Sine. So sine u, but I'm going to go ahead and plug it back in, sine 2x. All right, and then at the very end I'll add in the plus c, but for now this is the answer to our second part of our integral. So part 1 and 2, we got those. Let's go ahead and do parts 3 and 4. We're going to do 3 separately and then 4 separately. All right, continuing, I put our 2 answers so far down here. We're on the 3rd part of this integral, and I have it up here. And then remember what we talked about, this is like case 3 again because we have an even power on cosine. So we're going to use our trig identity that we used already in the same example earlier, the fact that cosine squared x is the same as 1 plus cosine 2x over 2. All right, so we're going to substitute that in. Now track with me, I'm going to take this 1/2, because technically it's a 1/2 if we're dividing by 2 here. I'm going to go ahead and factor that out. So I have a 1/8 already. I have another fraction of 2 on the bottom here, so I'm going to go ahead and bring those together and call them 1/16. And then the cosine squared of 2x. Now, also be careful here. I'm going to write this wrong on purpose. Whoops. Let's see. 1 plus cosine 2x is wrong. Okay, so wrong. Okay, see if you can tell why. Back here for our identity, this was for cosine squared of x. We're not even starting with that. We're starting with cosine squared 2x. So let me modify what we're working with. Let's see, so this is cosine squared 2x. So where we used to have just an x, I have to put a 2x. So what I really should have here, let's make this right, is a 4x. All right, so that's correct. So be careful, if your argument of your cosine is not just a regular x, adjust for it in your identity formula. Now this is not so bad. We can use u substitution on this. I'll go ahead and write it out really fast. U is 4x, du is going to be 4 dx, which gives us 1/4 du is dx. Okay, so we get negative 1/16 integral of this term is just regular x, so I'm not going to u sub there, it's just x. Then we have, let's go ahead and distribute this, so this is negative 1/16, and then I actually, let's not skip any steps. Let's plug this in. We have cosine u times 1/4 du. Okay, this is a 4. And so this becomes, if I take this 4 on the bottom out, let me just rewrite this first term really quick. 4 times 16, this becomes 1/64. And then let's just jump right into it. Integral of cosine is sine. So sine, and then go ahead and put back in what u was. U was right here, 4x. So this is sine 4x. And then we have a plus c. Okay, and that is our part 3 answer. So we're going to do one more, part 4. All right, our last part to this one integral, part 4. I did write our answer to part 3 down here. I did get a little bit ahead of myself. I put a plus c. I didn't really need to. I can wait till the end to do that. But we have part 1's answer right here, part 2, part 3 was here, and then we're working on the very last part. And notice what we said, this involves case 2 again. And so let's go through case 2 real quick with this integral here. And so, and recall I just brought this 1/8 all the way over here, that's why it's there, and the negative sign is out front. So what we have here, let's talk about actually the steps. So we did go over this in a different example, but let me walk you through it really quick as we go through here with this one. So step 1 was to rewrite this cosine as 2k plus 1 with the powers. So we're just going to say that cosine, in our case, cubed of 2x, notice your argument is 2x, not just regular x, that's going to be written as cosine squared of 2x, and then think about how to get a total of 3, that's k is an invisible 1, times cosine of 2x. Okay, so 2 times k plus 1, that was step 1 for case 2. And so I'm not really going to keep the invisible ones on there. And so far we have 1/8 integral of cosine squared 2x times cosine 2x dx. All right, moving on to our step 2. Step 2 from case 2, from cases 1 and 2, was to rewrite this squared quantity with your Pythagorean identity. And so we're going to go right into it. This is negative 1/8. This inside quantity here is going to be 1 minus, so remember cosine squared, so 1 minus sine squared is what that equals, but be careful to keep your arguments the same. So cosine squared of 2x is the same as 1 minus sine squared of 2x, okay? And then we still have our cosine 2x dx in the back here. Okay, that was using our identity, our Pythagorean identity, to rewrite this quantity. And then our last step for this process here, step 3, is going to be to use u substitution. So we're going to let u equal the sine 2x. Okay, so sine 2x, so that tells us that du, the derivative of this, is, so remember from your chain rule, I'll actually do it in parts so you can see it. I don't want to jump it ahead for you. Derivative of sine is cosine, keep the argument 2x, but times the derivative of the inside, derivative of 2x is 2 dx. Okay, so we're going to divide out that extra 2 because we don't see it here, so just to make this look a little better. Let me erase, because we're running out of room, but we've been keeping track. We are on the last part here, and then I'll keep our answer that we have so far down at the bottom. So I'm going to just go ahead and divide out this 2 from both sides. And so what we'll end up substituting in for du, we have 1/2 du is our cosine 2x dx. Okay, so let's plug this in. Let me just underline some stuff for you. Cosine 2x dx is 1/2 du, and then u is sine of 2x. So from here we have 1/8. Our integral of 1 minus u squared, and then all of this in the back was 1/2 du. Okay, and then we have, let's factor this out, negative 1/16 integral of 1 minus u squared du. And then I'm going to try to squeeze it in here. I know I'm making it a little tight. This is our answer all the way down here. Okay, we have negative 1/16. We're integrating at this point. Negative 1/16, integral of 1 is u. And then minus a minus, that becomes plus 1/16. Integral of u squared is u cubed over 3. So that's a times 3 there. Hopefully it's not getting too messy looking. Times 3. And then let's re-put in what u was right back here, sine of 2x. So this is negative 1/16 sine 2x. It's getting pretty squishy here. Let's go right there. Plus, this is 16 times 3, so 1 over 48. Sine, notice this is u cubed, so sine cubed of 2x. Okay, and that is going to go right into our answer down here. So I'm going to just erase this separation line, and that adds itself to our answer. And so we had this term plus this one minus this minus this minus this term plus this is our final answer. Wow, what a long one, but now you know how to do it. So if you find yourself going through lots and lots of steps, just take your time, stay organized. It is how it has to go. It is lengthy on this one. So hopefully this helps, and in the next video we'll go through different types of trig integrals.